All right, 1-6, day one of two. Day two is going to be newish. Today, you should have some foundation underneath you. You've done a lot of this in geometry, a lot of this in Algebra 1. It's just how fresh is it? So, this is a skill that's taught in almost every math class. It just seems to repeat itself, but let's just start. So, the title is Solving Systems. What's a system of linear equations? Well, a system is more than one. You see, we got two here, two here. Now you could have three, but that's not for today. Linear, don't forget, linear, root word, line, which is, these are all y equals mx plus b problems, equations, functions, and you're just trying to find where these two lines intersect. So, method number one, solve it by graphing. Now, some of you are addicted to Desmos. It's good, but there's going to be tests where you're not allowed to use technology. You have to show how your skill, you can actually compute this. But you can use graphing, and this, again, y equals mx plus b. B is my y-intercept, 1, 2, 3, 4, 5, 6. This is my slope. It's always two parts, rise over run, so it's up 2, right 1, there's my line. Second one, y-intercept, -1, down 2, right 3, 1, 2, 3, and then I go like this. And as you can see, it's going to be difficult to get this perfect, especially if there's fractions or decimals involved. So I could take a stab at it and go, you know what? It looks like it's -3, left 3, and then up 2. That would be my guess. So decimals, you can just type this in, put your cursor right over that, and it will tell you exactly what it is. You can see the disadvantage of graphing it by hand. It's not accurate. It's not perfect. So what's the answer to this? You know what? Not too concerned about it. I could go to decimals and figure it out, but I wanted to show you the disadvantage of graphing. So here's a good example where you can find it perfectly, and the technique is called substitution. There's another technique called elimination that I'm going to talk about in just a few seconds. This is substitution. Now, why does substitution work best in this? By the way, you don't have to use substitution, but see how this says y equals 3x plus 2? All I'm going to do, because this equals y, is I'm going to put it in the other one and substitute. So 2x plus 3 times what y equals, and that is 3x minus 2 equals 6. Now I want you to know something. We started with two equations, two variables. And by one little simple act of logic, we got it down to one equation, one variable. Now we can find x. So 2x plus, distribute, 9x minus 6 equals 6. Now I just made this problem up, so it could be anything. Now I'm going to add my like terms, 11x. I'm going to add 6 to both sides, equals 12. Divide by 11, divide by 11. I get x equals 12/11. Again, maybe I should have taken some more time and found an easier problem for this first sample, but I think you'll get the idea. Now, the question is, what are we trying to find? We're trying to find the x value and the y value where these two lines intersect. Now, I found the x value. How do I find my y value? Well, I can put this x here, or I could put it here. Now, to me, putting it here looks a little easier because I'm trying to find y. So I'm going to put it in that one. So y equals 3 times my x, which is 12/11, minus 2. So I get y equals, I get 36, because 3 times 12 is 36, 11th minus 2. Now, it's been a while since you guys have had to deal with fractions, but I got to find common denominators, so it's 36/11 minus 22/11, because that's what 2 is, and I would get 36 minus 12 is 14 elevenths. That equals y. What did we find? We found the coordinate 12 elevenths, comma, 14 elevenths. So if we actually graph these on Desmos, that's what our answers would be. But remember, Desmos is going to give you the answer in decimal form. So there's another thing. What if you're taking a multiple choice test and all the options are not in decimal form, they're in fraction form? You're going to have to be able to solve these by hand. So I'm going to show you elimination next. Okay, so here's the technique called elimination. Now the reason it's called elimination, some other books call it addition method. I'll explain that in a minute. But you're trying to eliminate either your x's or your y's. Now before we get into a sample problem right here, we got to have some basic foundational rules that we need to know that either, yeah, I can do that, or no, I can't. So here's an equation, 7 minus 3 equals 5. We know that's true. Another one, 9 plus 2 is 11. Now, what I'm going to attempt to do is take these two equations and add them together. Now notice my equals are lined up, and that's going to be significant. We'll talk about that in a minute. 7 plus 9 is 16. Negative 2 and 2 is 0. And then I get 5 and 11 is 16. So guess what? Check that box. It's okay to add equations. We're going to use that technique a lot. Why do I have this sitting here? Well, this is true. Now, what if I multiplied all this by 3? I just grabbed a random number 3. Distribute, distribute, distribute. I get 18 minus 6 equals 12. We get a different equation, but it's still true. So guess what that tells us? It's okay to multiply any equation you want at any time. Now, what if I multiplied this one by negative 1? Well, distribute, distribute, distribute. Just take the opposite. Now, negative times a negative is positive. Negative times a positive is negative. And then I ask myself, is that still true? Yes, it is. So on this one, I multiply by 3. On this one, I multiply by negative 1. Bottom line, it's okay to multiply any equation you want by anything you want if it's to your advantage. Now, here's your first sample problem of elimination. It's the easiest one there is, because if you look at this and I think about, you know what, I'm going to add these together just like he said I can, and I look at my y's, I got a negative 4y and I got a positive 4y. So if I add these together, these cancel. And I get 5x equals 10. Divide by 5, I know x is 2. And now to find y, I could put it in the bottom one or the top one, it doesn't matter. I'm going to put it in the bottom one, so 3 times 2, because that's my x, I just found it, plus 4y equals 4. This is 6, so I'm going to subtract 6 from both sides. 4y equals negative 2, divided by 4, divided by 4, I get y equals negative 1/2. So my answer would be 2, negative 1/2. It's easy to screw these up, put your y where your x value should be, vice versa. So be careful in that final step. Why was this one so easy? Because we already had opposites, and we eliminated the y's right off the bat. Is that the way they're all going to be? No. I'm going to put up a couple examples of those, and then we should be close to being done. Okay, so here's one that's a little more challenging. Notice they aren't even lined up. You know, normally you got your x's, then your y's, then your equals, and your constants. The word constant is another word for your numbers. So that's what we're going to try to do here. So what I'm going to do is I'm going to take these and I'm going to reverse them so that my x's come first, then my y's, then my equals, then my constant. Is this the only way this will work? No, but this is kind of the traditional way of doing it. Now I look at this, I'm like, oh, I got to get that 2y away from there, and I'm going to add it to both sides, rewrite it, put my 3x first, then my 2y second, and then my constants are 4. Now everything's ready to go. Now I want to show you something. In the previous example, once they were like this, we just added them together. We got 2x plus 5y equals 10. Listen now, this is not wrong, because it's okay to add equations. It's just not helpful. Remember, what we're trying to do is eliminate one of these variables. So in the previous example, why was that one so easy? Because one of them were already opposites. The y's, one of them was 4y, one of them was negative 4y. So that's our goal. So what I'm going to do is I'm going to take a look at this right here and this right here and ask myself, how can I make these opposites? Remember our second rule, we can multiply any equation we want by anything we want. So I see that that's a 3x. What I want is a negative 3x, and then I'm going to add these two together, and then they will eliminate. Well, how do I get that from this equation? I'm going to multiply this top equation by a 3. So I get that, gives me negative 3x, that's 9y, and this is 18. Now I'm concentrating on these two equations now. I don't really care about that one anymore, because now I see these two equations. I'm going to add them together, and the x's this time are going to eliminate. Then I get 9y plus 2y is 11y, 4 plus 18 is 22, and we like it when these work out so nice. Y equals 2. Now don't forget, that's going to be the second thing, because remember it's x, then your y, and your answers. How am I going to find x? We could put it in this one, or this one. I'm going to go back up to the top one, which says negative x plus 3y equals 6. Put the 2 in for y, so negative x plus 3 times 2 equals 6. And I know this is 6, so I'm going to subtract 6, and I get negative x equals, see these cancel, 0. Well, technically, if I multiply this by negative 1, that's what you're supposed to do. You get x equals, and I got to multiply both things, I still get x is 0. So that would be my answer there, 0, 2. As you can see, it took a little more work. Now, there's more to this. We're almost done now. All right, grand finale of the pre-lesson. Just so you're kind of on your guard, whether it's substitution or elimination, there are 3 possible ways you can find a solution. Three things that two lines can be doing. Number one, 99% of the time, they're just going to intersect and you're going to find an answer. Now, I'm not saying these 2 lines are these if I were to type these in decimals. I'm just showing you a random drawing. And as I showed you earlier, these are easy because I can see the 2y and the negative 2y. If I add these two together, I get 2x equals 7. And I might as well make this a 5. Make our lives easier. 8. X is 4. And then if I type that in right here, I'm doing a lot of math in my head, but 4 plus 2y equals 3. Subtract 3, I get subtract 4 from both sides. I get negative 1. Divide by 2, I get y equals negative 1/2. So my answer is 4, negative 1/2. Okay, that's your typical math problem, but it's an easy version of it. I just want to show you, you find one answer. Now notice these are parallel lines. We're trying to find where they intersect. They don't. So you're starting a math problem. You don't know they're parallel yet. And you go, you know what? I see that these two are opposite, so I'm just going to add them together. They cancel. And I go, uh-oh, y plus negative y, they also cancel. And then I get 8. Is this a true or false statement? It's false. When it's a false sentence, you go, they never intersect. So there's no solution, or you can say they're parallel lines. I mean, you just have to know that that whole picture's happening. Last unique thing that happens, if you take a look at this one and you ask yourself, if I divide all of these by 2, you'll notice, what's 4x divided by 2? 2x. What's 6y divided by 2? 3y. What's 10 divided by 2? 5. So, well, let's say I didn't notice that, and I tried to, let me check on time here. Just realized we're running out of time, so I'm afraid we're going to have to do a part 2 on this video, but it won't take long. So we'll see